Hello, everybody. We're here at Noisebridge in San Francisco. This is the Python class. We are on lesson 3 of the Python class, and this is a repeat. We've already done lesson 3 earlier a few weeks ago, but we're repeating it as we do with classes now in the new series so that people have a chance to see it multiple times, or if they miss a week, or things like that. So this week is lesson 3, and let's get started. So in this lesson, we're going to be discussing more of the basic building blocks of Python programs. I'm going to talk a little bit about literals, expressions, and statements, and how they relate, just so that you can get an idea, like when you're looking at Python code, like how it kind of gets broken up, like into parts that the Python interpreter understands. Then we'll talk a little bit more about data structures, and then near the end we'll discuss exceptions. So exceptions are basically, errors. Like I say here, we're all familiar with the basic concept of a computer error. Obviously, if you haven't gotten a computer error, what a blessed life you have lived, let me tell you, up until this point. But in Python, we use exceptions, like is a specific thing, and it's used to more precisely define, reason about, and handle errors. So we'll talk a little bit about exceptions at the end. So let us dive in. Literals, expressions, and statements. So literal is a specific value, a piece of data in code. So these are all literals. This is a numeric literal, an int literal. Here is a Boolean literal. This is a string literal, and this is a list literal. So basically the difference between a literal and non-literal is that like the literal, the data of the literal is in the code. It's in the source code file. Whereas like hello world, it's right there in the code, right? Whereas if I was like reading from a file and I said like messages.txt, what's the message? And I read it from a file, it could be anything, right? It might be hello world, but it could be anything else. So that's not a literal, that's like data I'm reading into the program. Literals can be assigned to variables. So we've seen a lot of this already. Literals aren't the only things that can be assigned to variables, of course. An expression is any bit of code that evaluates to a value in place. So when Python sees an expression, it calculates what it evaluates to and kind of like replaces the expression with that value. So like when Python sees 4 plus 2, it kind of replaces it with 6. And a function call is an expression. So if I'm calling sum on this list, it evaluates to 10. Expressions can be combined. So you can think of like, the schema for the plus operator is like expression plus expression. You know what I mean? Like, and then that is an expression. So that can be on the left of a plus sign, right? Which we'll see here. Like, what I'm talking about is like, if you have like, so like, right, so that might be the plus sign expression. So I have like 42 plus 5, but then I can put, 42 plus 5 on the left and 20 on the right, see? So, and then I could replace, 20 with, 10 plus 10. So like, that's kind of the whole idea of expressions, is that they can be like expanded and contain sub-expressions. So here's me setting D to a literal dictionary. This is a dictionary literal. I'm not sure how that relates to the lesson or where it came from, but I apparently put it there, so great. And then here's an expression containing sub-expressions. So now I'm saying sum of 1, 2, 3, and then 2 plus the sum of 1 and 1, that's 4, right? And then the max of, oh, that's why I made this D. So because like like a dictionary lookup is also an expression. So here I'm saying like the max of 5 and the value of the key foo in the dictionary D, which is 3. So the max of that is 5. So then when we evaluate this expression, we get 15 because it's the sum of 1 through 5. Oh yeah, it gives you the max. So it's like if you did like max, 10, 5, -12, 50, 4, or whatever, it'll say 50. There's also min, so if I did min, it'd be -12, right? Yeah. But that's the point of the expression, because I'm saying that like I could also replace this with 5 times 10, you know what I mean? And then here I could replace that with sum 2, 3, you know what I mean? And then, so like, expressions can expand with individual parts being replaced by other expressions. Let's get rid of that. Oops. Okay. So now, an assignment, that's what we call when we store value in a variable. It's called an assignment. Is not an expression. Assignment is not an expression. That's the important part. So assignment is a statement. And a statement is, loosely speaking, a bit of code that is on its own line in a Python program. That's the basic way you can think about statements. So here's this assignment. So the expression 4 plus 2 evaluates to 6, and we store 6 in the variable x. So since a statement has to live on its own line, you can't put statements in places where you could put expressions. That's kind of the easy way to know that, like, oh, a statement lives on its own line, so I can't just kind of shove it into the middle of an expression like I was doing with the other expressions. So here's expressions. We can print the expressions. This doesn't work because I can't do the sum of these numbers plus x equals 42. This is assigning 42 to x. That's not an expression, so I can't add it to this sum, right? And then this is also an error. This is just kind of nonsense, but I'm saying like, if 4 is greater than 2, like that's the if statement is a statement, it's not an expression, so I can't like stick it in there. Okay, so here is the important part. All literals are expressions, and all expressions are statements. So picture the Venn diagram that I'm too lazy to draw. So basically, you have your literals here, then expressions. All literals are expressions, and all expressions are statements. So here, like, even at the very beginning, like I had this stuff, like 42, that's a literal, it's an expression, and it's also a statement, right? Because it's like, it's a statement that doesn't do anything, but it's like, it's on its own line in a Python program, it's a statement, So here's an exercise. Who's done this exercise before? Write 5 literals, 5 expressions, 5 and 2 statements. No? You have? You have not. Okay, great. So we can do this exercise. It should be pretty quick. Don't overthink it. So you just want literals, kind of like the ones I had up here. Then these are a bunch of like expressions in here. So you just want like 5 literals, 5 expressions, and then 2 statements that use your literals and expressions. Cool? All right. Okay, let's move on. Okay, so let's just write some literals. 50, hello. Yes, 1, no, 0. Foobar Baz, great. And then 34. Okay, so there's 5 literals. Here's some expressions. 5 plus 5 max is something like that. Great. What else can we do? Sum of 1 plus and 1 plus 1 plus 1. Print 42 is technically an expression, but we'll talk about that in a second. And I need one more. Okay. New York starts with new. There we go. Okay. And then my statements, x equals 5 plus 5, and print 42 is a statement, so that's fine. Cool. All right. So now this is I'm gonna insert. See, next we're supposed to go on to dictionaries, but I want to talk about none type. So one thing, I guess I didn't actually state this explicitly, and I want to add this back into the lesson too, is that function calls are an expression, right? So we saw that with like sum and max, maybe we were using as expressions. So like we could do like 5 plus sum 1, 2 equals 8, right? So this function call is an expression, right? And we saw this in the previous lesson or maybe that's this lesson. Never mind. Anyway, it's because I already did this lesson once, so yeah. That's why I'm confused. But so this is good. So I can also do like, x equals some. So like I could do like n equals 10, m equals 100, and then sum equals sum and m. Difference, yeah, sure. Why am I, yeah, well, okay. And then, so you can use like expressions in places like that, right? So what about print, right? So, or if I even just print x, let's just print x. So this prints the dictionary, sum 110, difference 90, which is great. But what if I did like y equals 5 plus print x, right? Because we said when I call a function, that's an expression. And I was already talking about how like, you can replace expression with like multiple expressions, right? Like we did 5 plus 5, but we do like 5 plus 2 plus 3, right? So what if I do 5 plus print x? Let's see. I get a type error, and it says unsupported operands for plus, int, and none type. So 5 is the int, and none type is the return value of the print statement. So if I just do y equals print x, and I do print y, I'll see that first it prints the dictionary, right? That's print x. Then when I print y, it prints none. Y has the value of none. So what is none? None is the absence of a value. So if you know other programming languages like MySQL or whatever SQL, there's like a null in SQL, there's nil in Ruby, there's null in JavaScript, there's like null pointer in C++, stuff like that. So it basically means that there is no value. So like if I had a number, it could be 1, it could be 2, it could be -1, it could be 0, or it could be none. So none is not 0, right? None is not -1. None is it has no value. So same thing, if I had a string, it could be like hello world, it could be an empty string, or it could be none. If it's none, it means there is no string. There's nothing, right? So that's what the error was giving me a second ago, is if I did this, it's saying like, I don't know how to add 5 and none, because none is not a number, right? So it's like, it's just nothing. So I can't add 5 to it, right? So if you think, another thing you could do is like, if I did like, x equals hello plus world, oops, I already used x, y, oops, print y. Okay, so it prints hello world, right? Because I used the plus operator to concatenate two strings, to merge two strings together, right? But if we do hello plus none, can only concatenate string, not none type to string. If you see error messages that say none type, they basically mean none. The type of none is none type, so it's just kind of, semantics, but so like again, I can't add none to a string, right? It doesn't make sense. It has no value, right? You'll also see, sometimes you'll see like y equals New York, and then like I print y, and then hundreds of lines of code later, I do like y equals print x for some reason, because it's a bug, I didn't mean to do that. And then later I do like print y dot starts with new, right? This is also an error, right? So here's the first print, New York. Then it prints the x, which is the dictionary, right? And then it goes to print this. Does y start with new? And you're like, well, it's New York, so it does start with new. That should print true. But no, y in between, I reassigned y to the result of print x, which is none, right? So then when I say none dot starts with new, it tells me none type has no attribute starts with. So if you ever try to call a method on none, you're going to get none type object has no attribute, whatever method you tried to call. So even if I tried to do like y dot foobar baz or whatever, right? This isn't an error that foobar baz doesn't exist. This is an error that none has no such method, right? Because none doesn't have any methods. It's nothing, right? So anyway, good to keep in mind. Just a little primer on the none type. So a lot of times, and a function that doesn't return a value returns none. So that just assigns to a variable x, n equals returns. So this returns none function, notice that it doesn't really do anything. It just assigns 4 to x, but then just exits, right? So because it didn't return anything, it returns none. And when I print n, it prints none. Oops, what does it do? I'm getting the foobar baz again? Oh, this. I forgot to delete that. And that is an error, right? So I have to comment it out. Okay, now when I do it, okay, so it printed New York, the sum and the difference, and then for n, see, n is none. So this function returned none. So the same thing would happen if you do like 2 plus, what am I going to get if I do that?
None. You can't.
Yeah, so I'll get that same error, right? Like type error, can't add into none. Yeah, exactly. Yep. So actually, when you think about it, print isn't that weird because I could have tons of functions that I define that don't return anything, right? And they implicitly return none. Okay, I'll clean that up for the next time I run this lecture. Okay, questions about literals, statements, expressions, assignments, and none. Okay, let's move on to more on dictionaries. So if you don't remember, dictionaries map a key to a value. So albums is a variable. It's being assigned this literal dictionary. The keys are Beatles albums names, and the values look like the year in which the albums were released. So I have the key, which is this string. I have a colon, and then I have the value. Then I have a comma, which means here comes some more keys and values. So that just repeats 4 times. We can use numbers and strings as dictionary keys. We can use other hashable objects, such as tuples, but we can't use lists or dictionaries as keys. So if I say like fruits equals, I was like apple, banana. So I'm trying to say like, oh, the apple and the banana and the cherries and the grapes, cost are more expensive, $2.89, right? So you see what I'm kind of trying to express here? I'm like, oh yeah, apple and banana cost this, and cherries and grapes cost that, right? This doesn't work. Unhashable, there's that word again, hashable type list. So what is a hashable type? It's basically a type that the value doesn't change, is one way of summarizing it. But there's a more precise definition out there somewhere. But it's basically like, if you have a object, it's hashable if I can convert it to like a number, and then that same number refers back to that same value, right? So a list and a dictionary aren't hashable because a list can grow and shrink. So the identity of that list can change, so it doesn't hash to the same value once something is added. Okay, and then the value assigned to the key can be any expression. This is why we talked about expressions, including literal strings, numbers, lists, tuples, and other dictionaries. So we have another dictionary literal here called almanac, United States and Russia with population numbers, capital, largest city. Notice that cities is a list, population is a number. The values don't have to all have the same type, right? So I can have a number here, but then a string here, but then a list here, and so on. But even though I can put anything for any key of the dictionary, we generally try to have them have a standard shape in our programs. So like here in this almanac, all the top level keys, like this dictionary, almanac, has 2 sub-dictionaries, right? Like in the pink here, these are dictionaries, right? So it's a dictionary within a dictionary, right? And so here, the key is the name of the country, and the value is a dictionary with data for that country. So here again, key is the name of the country, value is a dictionary with information on that country, right? And then these 2 dictionaries, the United States dictionary and the Russia dictionary, you can see that they have the same shape, right? They have 4 keys, population, capital, largest city, and cities. They both have the same key names, right? And then the value for the keys are the same, not the value, but the data type for the keys are the same, right? Like population is a number, capital is a string, largest city is a string in both cases. And cities is, also a list in both cases, right? That's good.
Can you use a different number of cities in one list?
Yes. What I'm getting to is that this is set up so it's like the same shape, right? Like the data's in the same kind of place. Like the values are different, but like the names of the keys and like what type of value are all the same. That's what we call the same shape. What I'm getting at is that you don't need to do that. Like there's nothing keep making you do that. The fact that this is done this way is just because I'm like trying to organize my program in a sane fashion. But I'm about to show you like it doesn't have to be like that. So yeah. So here's like an example of like another thing I could have done, right? Like here now I have silly land, population banana. So now this is a string and this is a number. So that's a problem, right? Because if I'm running through all these dictionaries, I'm like, okay, get all the populations and sum them maybe, right? But then I'll get an error because it'll be like, can't sum a number in a string, right? So that would be a problem. And here the capital is 12. It was supposed to be a string, And then here the cities is this list, but it has some junk in it. And this has favorite color, orange. Whereas United States has largest city. So like they don't have the same keys. So if I was iterating over the almanac, I might think like, okay, now it's time to get the largest city. And then I might get a key error because silly land doesn't have a largest city key, right? So that could be a problem. That's actually kind of a good use of just like the none type, right? If I did like largest city, none. Like silly land doesn't have any cities. So the largest city is none, right? That makes sense because there is no largest city. It doesn't have any cities. But that's kind of the main point of this example is that like this is not a good way to design your data. Back to your original question though, it does make sense. Like I have 3 cities in each of these, right? But like in this case, even if the United States had 4 cities and Russia had 3, you would consider that the same shape because like the number of cities in the list doesn't really matter. Like it's more like here's a list of cities for the cities key, right? Okay. And then we can use any expression as the value of the dictionary. I kind of showed that a second ago. So here I have pop in millions, which just returns 328.2. So then I say the population is pop in millions times a million. Not too interesting. So then the population is the same as it was before because that expression got evaluated. Notice that it doesn't say population, pop in millions, whatever, right? Like Python ran this code, evaluated it, and that's the value that goes into the dictionary, right? Oh, and then here we see I sliced the cities. So I said only New York City and Los Angeles should show up here, right? Yeah, New York City and Los Angeles. And then when we access the value of a key in a dictionary, we use slice notation. So almanac slice United States gives me this subdictionary. So if I print that, yeah, that's the subdictionary. And then United States is also a dictionary, right? So we can slice further. We can say Almanac United States, this dictionary, and then get its population key. So we're saying like United States, so we get this value, right? And then we say, oh, and I want the population key from that dictionary. So it's almost like Almanac, oops, I don't want to drag that. Almanac United States gets replaced by this, right? And then I say that dictionary population. So let's see, and I get the population. So we can slice using any expression, but usually we're going to just use a string or number or a variable. So here is kind of silly. So country equals United States, so it's going to be almanac country. And then what key of the United States dictionary are we going to get? Like what is this going to print? Eulation. That's what this does, right? Eulation. But what's soda?
Oh, population.
Okay. The soda thing was kind of a dumb joke, but yeah, so now it gives the same value as this, right? Because this expression, soda plus get rid of key, evaluates to population. Right? Yep. Okay. And remember that trying to get the value of a key that doesn't exist is an error. But if you look at this, it kind of makes sense. Like, I want the value of Germany, right? It doesn't exist. So then I can use an assignment statement with the dictionary reference on the left side to make it exist. So for Germany, I've got this stuff, and then I print the almanac, and then Germany is in there. Okay. Questions about dictionaries? Okay, let's move on to more on lists. More on lists. A list is an ordered sequence of values. Like dictionaries, the values can be any expression. So here now we have, I'm calling this variable United States. And then I have a population, a couple of cities, and then get cities, which returns this list. So when I print United States, the first value is the population in millions, Washington, D.C., New York City. And then the fourth item of the list is also a list. So just like dictionaries, lists can be inside lists, dictionaries can be inside lists. Actually, dictionaries inside of lists make sense if you think about like this almanac. Maybe I just have a list of countries, right? And each country is a dictionary. So I have a list of dictionaries, right? Here's slice notation. And so United States 0. Actually, let's see.
And then the 0, the 3, the -1, are those just the...
We're going over those.
Oh, absolutely.
So here, remember, this is United States, right? This is the list. So again, I'm saying we've already seen it, but I'm just going to run through them quickly. The indices start at 0. So United States 0 is the first element in the list. United States 3 is the fourth element in the list, which is this sublist. United States -1 is the item at the end of the list. So it's again the same thing, the sublist. United States 1 up to but not including 3. So the second element and the third element, but not the fourth. So it's just these two, because it starts at 1 and it goes up to and not including 3. There's nothing on this side of the colon, so it starts from the beginning and it goes up to but not including the last element. So everything but the last element, so it's the first 3 elements. And then from the third element at index 2 until there's nothing here, so until the end. So we see all those things. technically we covered this in lesson 1, so it's like I'm not going to spend a lot of time on it here. But here's just some examples of slice notation. And then trying to access data at an index that doesn't exist is an error. List index out of range. It tells you pretty clearly what the error is. We use append to add to a list. So my fruits are an empty list literal. Then I append some string literals. Then I print the fruits, and I get a list of fruits. I can use pop to remove the item at that index. So pop fruit equals fruits.pop1. So if I remove that item at the index and return it, what is the pop fruit going to be? What's the item at index 1? Banana, right. And what's the list going to look like after I pop it? That's right. Let's see. Yes. So the list is just apple and cherry, and it popped banana. And I think we covered this last week, but tuples are like lists, but immutable. So a tuple is defined using parentheses rather than brackets, but it otherwise functions just like a list. So you can slice it. So here I can create a US tuple. I can slice it, and then here's this weird thing that you should know in case you're using tuples, that like since we use parentheses for grouping, because you can put parentheses anywhere in Python code, right? It's saying like do this first, just like in math, right? But we also use parentheses for defining tuples. So here I have n, a again, and tuple, right? So when I print these out, n is 6, right? It didn't create a tuple with one item in it, right? A is apple. A again is also apple, right? Because I just put parentheses around it, it's still just apple. So if I want a tuple with one item, I have to put a trailing comma. That's the weirdness, right? It's pretty funky. So a tuple with one item has a trailing comma. And that's how we know now this is actually a tuple. No, I see the look of befuddlement.
Question.
Yeah, go ahead.
So are we going to run it to arrays? Do they have arrays in Python?
No, there's lists. They operate similarly to arrays.
Okay. Good, thank you.
It wasn't a question about how weird this comma thing looks.
Oh, it's weird. Yeah.
But you see the difference between A again and A tuple, right? Like A is apple, A again is just apple again, because I can put as many parentheses as I want, around this, right? Like, just like in high school algebra, right? Like you put as many parentheses as you want, it doesn't change anything, right? So if I really wanted to change something, if I really want to say there's a tuple with one item, I have to put the trailing comma. But also I can do like, if I have multiple things, now Python already knows this is a tuple because there's something coming after the comma, right? It's like this, like if I did like z equals, like that's not a valid expression, right? Banana comma apple is not it doesn't mean anything. So when Python sees that inside of parentheses, it knows, oh, you're defining a tuple. So you don't need to put a trailing comma here. You can, but you don't need to. But if there's only one item, Python can't tell the difference between I just used some random parentheses and, hey, I wanted a tuple, Yeah, so. All right, and then there's sets. Sets are unordered collections of unique elements. So it's basically like something can only appear in a set once, and they're unordered. So here's a couple of ways of defining them. You can use the set constructor, the set function, and pass in an iterable. Or you can pass what looks like you're making a list, but you use curly braces. And notice that when I print out fruit set, it prints it with the curly braces. Also, an important thing to realize really early here is that fruit set, I defined it as apple, banana, cherry, but it printed out cherry, banana, apple. Why is that? The reason is because it has no order. It's like the keys in a dictionary, there's no order. So there's not like, oh, I put in the apple first, it should be first or something. It has, the order is undefined. It doesn't have a consistent order. So you can iterate over sets, but if you iterate twice, you might get them in different orders each time. Okay, so if we try to add another banana, nothing happens, but we can remove it. So if I try to add another banana and then I print it, it's still cherry, banana, apple. But when I remove banana, now it's just cherry and apple. Removing an item that is not present is an error. Key error, kiwi. And then we can use this in operator, which is the same operator we use for checking if a key is in a dictionary. So I say like apple in fruit set. It's just it evaluates to true or false. Like, is the apple in that set? And that's the same as like if I had this fruit dict, I could say apple in fruit dict, and I'll say true both times. So that's the way, like, if we're writing a program that uses a dictionary to like keep track of things, you know, like, oh, every product I've seen, I've assigned a price to. Here's a new product. I'm like, have I seen it yet? So I check if product in products or seen products or whatever, right? You also think of this as like, the set is good for operations. Like, here's another, here. The set is good for operations where you're like, oh, I've got 1 million people at my customs line, and I want to keep track of which countries they're from. Okay, Germany, Chile, Poland, Germany again. Like, you can just put it into the set, and you don't have to check first if it's already there, right? Because if it's already there, nothing will happen. But if it's not, it'll get added. So that's kind of like the use case for the set data structure. Here's another set here where we have like Germany on here twice, and the United States is on there twice, and then when we run it, it only has the unique values. Make sense? Okay. This is a good one. This is a good exercise. So what we want to do is we want to write a data model that is at least 10 lines long. You know, I just have to say that because people will be like, x equals 5, I'm done, you know, like whatever. But basically you want to model some real world thing. Here I have sea creatures, kind of like the almanac you saw above, right? Basically we're basically doing something like the almanac, but you want to use a dictionary, a list, a tuple, and a set. And you just want to think about how to shape the data so that it makes sense. You know, like, do I have each country as a dictionary, or do I have each, and then like the cities, are those dictionaries with data about the cities, or things like that, right? It shouldn't be almanac. It shouldn't be sea creatures, because I already started that one off. Just any real world thing that you want to like capture data about, okay? And it should be 10 lines long, and you should use a dictionary, a list, a tuple, and a set. Cool? Cool. Okay, so let's see what we have here. It's a squid is a cephalopod and a mollusk. I'm not sure what I was going for here, but I know that like. There we go. But basically something like this. So something like this is what we were looking for. Okay. More on for loops. So in other languages, you often construct for loops with a loop variable, which counts how many times you've been through the loop. So this is JavaScript code, but I'm basically saying like I equals 0, I is less than the length of the data, keep adding 1 to I, and then we process the data at that index. So it's like 0, 1, 2, we process each element of the data. The for loops we've seen, like this, for fruit and fruits, it just produces the individual items in the list, right? But what if we need the index? What if we were saying like, the first 3 items, the first 3 fruits are on discount, but otherwise it's not. So I can kind of keep track of this with my own loop variable. Like I can start I equals 0, and then I start the counter, I is less than 2, so it's on discount, blah, blah, blah. I add 1 to I. So then when I get to the next fruit, I is 1. Then I get to the next fruit, I is 2. And it's not less than 2, so it just prints the fruit. So apple and banana will be on discount. The rest will not. Oh, sorry. If I is greater than 2, so everything but the first 3 are on discount. Got it. Anyway. But you can see how I do this with like, I set I equal to 0, and then I'm checking, and then I add 1 to it. But there's a better way. It's called the enumerate function. So the enumerate function wraps an iterable. So you wrap it around an iterable. Basically, you call it with the iterable as the argument, right? And it produces tuples of index and item. So here I say like for I comma fruit in enumerate fruits, and when I run this, I get the same thing I got before, apple, banana, cherry, discount, date, line, pair, which is what I had up here, right? This is the same thing, except I don't have to like keep track of the loop variable myself. So there's this enumerate thing that lets you keep track of the index of the list. And then this also demonstrates unpacking, which is just like something you might see. So I can have like x comma y equals 50, 500. And then it puts 50 in x and 500 in y. And then if my fruits equals this whole list, I can do LBP equals fruits, and I get the lime, banana, and pear, each one out of it. It's not super common syntax, but you will see it. And honestly, that's actually what's going on with this I fruit thing, is that I'm actually unpacking the tuple that's coming from the enumerate method. So here, if I use enumerate again, and I assign it to a single variable, fruit tuple, then you see this is what enumerate actually produces. 0 apple, 1 banana, 2 cherry, right? But when I say like I comma fruit, it's the same as doing it this way with the parentheses. Oops. like 0 apple, 1 banana, 2 cherry, I comma fruit. It unpacks the tuple for me. So see it again. Those are the tuples that enumerate produces. And if I unpack them, I get the individual items out of the tuple, which is the same thing as what's happening like here with xy equals 5500. Because the tuple is 0 apple, so I becomes 0 and fruit becomes apple. Does that make sense?
Yeah. And then the
No?
enumerate is just the 0, 1, 2 before it.
The enumerate, yeah, assigns a number to each item. And it returns the item as the first item of the tuple. Okay, cool. So let's look at exceptions. So exceptions interrupt program flow. It basically represents a condition that a running program either didn't expect or can't recover from. So as you're running the code in these exercises, you'll probably see like syntax error, unterminated string literal, name error, blah, 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 like all these exceptions from your code as you run it. And those are like syntax errors are exceptions. They're a kind of exception. You can also, we saw exceptions earlier in this class about like adding int and none type, which is a type error, right? You can't add none to an int. That's a type error, so that's an exception. And if you have an index in a list that doesn't exist, that's an exception. A dictionary key that doesn't exist, etc., right? And it could be like you're trying to read a file that's missing or connect to a server that times out or all kinds of stuff, right? So those are where exceptions happen. Those are the kind of things that are exceptions. All exceptions in Python are subclasses of base exception. Don't worry if you don't know what a subclass is. We're going to have an object-oriented class soon. It basically means that any exception is a base exception. And then blah, 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 blah. Base exception includes exceptions like you don't want to catch necessarily, like system exit, which is like, oh, the program is quitting. And that's an exception technically, but you don't really want to catch it. Like if the program's quitting, you want to let it quit. So we don't do that. I don't know why I included this paragraph. It's just confusing. All right, what does it mean to catch an exception? Here we go. Here's some code that will throw an exception. It throws a value error because what I'm trying to do is I've got a bunch of numbers, number strings. I'm trying to convert them. So I use a for loop for string and number strings, and then I try to convert each string to a number using the int function. But when I get to this number, question mark, it's not a number, it's the letter X. So I get this exception, value error. Invalid literal for int with base 10, X, not a valid integer, right? So when the exception is raised, all program execution stops immediately, and the Python interpreter starts looking for exception handling code. It starts searching around. Okay, wait, something happened. Can someone handle this? Like, is there anything declared to like do something about this? If it can't find a handler, it raises the exception to the top level of the program, like the very top, like where your script is running, and then it exits. It crashes, basically. So it doesn't crash, like when I'm doing it in the notebook here, it doesn't crash, obviously, because the notebook environment is set up to like catch the exception and print out this nice message for me and stuff. But if I was like, apologies to the stream and the video, I'm in my console and you can't see it. Let's see. Actually, let's try this. Okay, so let's put that code that we just had. This is just to, I mean, I know you believe me, but I just want to show you. So if I do Python exception.by, so like my program crashed, right? If I did like no exception.by fruits equals. Okay, so if I do Python no, so that program just prints apple, banana, cherry, right? But this program crashes. It doesn't print out what it was supposed to print. So that's what I was just what I'm trying to demonstrate. Well, I guess I could run this in the console to show this. Would this do something? Oh no, no. Oh my God. Okay, new terminal. I'm just running that for the sake of the stream. Sorry. That's what we just saw on my console. Okay, great. Oops. Okay, close that. All right. So we see that when I try to convert x to an integer, that raises an exception. The exception crashes the program. Great. So now it's very obvious to us that like, hey, I have a bunch of numbers, but there's an x in it. So fix it by removing the x dummy, right? But in the real world, you could be reading this data from a file and like you don't know, someone gave you the file, it's got a million lines in it, you don't know what's going to be in it. And maybe there's just some stuff in it that's supposed to be numbers, it's not numbers. So that's why we have to kind of be able to handle those cases. So here, I've included this try block, try colon, then I have a bunch of code to run in that block. Then I have except, and then code to run in the except block, right? So what happens is that it gets here, try doesn't do anything on its own, it just introduces some error handling potentially, right? I start running my code like I was before. When I get to the x, the exception happens, right? But remember what I said. When the exception happens, Python tries to look for code to handle it. So then it finds this except block, right? Oh, it was a value error. Oh, I'm catching a value error, right? Then it'll print out could not convert some values and the value. And it says done converting the numbers. So here, the program didn't crash this time, right? But what does my converted numbers equals? 1 and 2. Why doesn't it include 4? 4 is a valid number. Then it stopped, exactly. When it got to the x, it crashed, kind of. There was an exception. It went to this except block, right? But then it didn't go back into the for loop, right? It doesn't know how to get like back into the middle of the code that crashed, right? So it just continues on from that point. So it successfully converted the 1 and the 2, and when the x appeared, it got an exception, but at least you got some of the values, right? Also notice that this e, when I say as e, basically I'm saying like whatever exception, whatever value error happened, stored it in the variable e, right? And then in this, my error message, I can just print out e like a string, right? It'll get converted to a string. And when it gets converted to a string, it has the message of the exception, which is actually kind of nice, right? Because if I just said, like, if I just did this, could not convert some values, done converting numbers. It's like, oh, so you couldn't convert some. Okay, well, it'd be nice if you let me know, which ones or anything else about that, So you can see that, like, this is actually kind of nice to put the exception message in there. So yeah, converted never got the value for 4. So a better way we could write this, actually. So now I have converted and rejects, right? My number strings are the same as they were before. So now I say for string and number strings, try to append the conversion. And if there's a value error, you can put that in the rejects. And now it says converted 1 to 4, but found 2 rejects, x and foo. So that try can appear anywhere that a block can appear. Notice the difference between the two code blocks, right? Here I have the for loop all within the try, but here I start the for loop and then I try the thing that I think could create an exception. So in general, you should only catch exceptions if you intend to do something meaningful with them. Like, even if it just means logging it, even if you're just going to write a line that says, hey, something happened, I didn't know what to do, I'm going to keep going, whatever, right? But it is possible to swallow exceptions, and that's demonstrated here with, if I get an index error, it just says pass. Remember, pass is the no-op keyword in Python. It just means do nothing. But you can see the problem when I run this code, right? Oops, X is not a good example. Okay. So here I had some numbers. There's 3 numbers, and I say my num equals my number's 5. So the 6th number, right? But there's no 6th number. That's an index error. And let's say I wrote this code like this, right? And it was like, index error, list index out of range. And I'm like, oh crap, I'm getting an index error. I know what I do. T-Money taught me about exception handling. So all I have to do is wrap this in a try except, and then when the index error happens, I won't get my error, right? Well, it doesn't work because now my num isn't defined, right? It's like you're trying to get that thing. It got to here, it evaluated this expression, which raised the error. It got to here, which is just do nothing. And then it went on to try to print my num. My num doesn't exist. It only got it defined after the list lookup, which never happened, right? So this is not a good strategy necessarily. Sometimes, like very occasionally, it can be useful, but in general, it's not a good strategy. Oh, I guess I didn't introduce my next thing is the pass keyword. Apparently, I never introduced pass until... This is the problem with doing the lessons over again, because I'm like, oh, I already taught that. But it's like, no, I taught it the first time I taught this lesson, which is like, I can't assume that for this. Sorry about that. All right, anyway, so pass is just a do nothing, no op. It just, keyword just means do nothing. So let's say you're like, you can't do this. It says incomplete syntax error. It's like, even if I had like def foo, friend foo, like this is not, I get an indentation error because it's like, what are you doing? So basically you have to use pass. So if I put pass here, let's say I'm gonna come back and write that function later, right? Now this works. So this does not work. Oh my god. And this does work. Pass. All right, back to exceptions. So we can catch multiple exceptions and can accept value error, index error. So when I run this, it says could not convert some values list index out of range, which is the error happening here when I try to access index 100 of converted, which is out of range. Because here I'm catching either a value error or an index error. Whichever one of these happens, just catch it. Oh, maybe this isn't clear. If there's an error that you're not catching, like if you're not catching, here I do like, so like here I still get the index error, right? Maybe I need to make this more clear. Like I have the try, I have the accept, but when I try to get converted index 100, it's an index error, right? Because I'm not catching index error, I'm catching value error. That's the important part of this. So Python will only catch the exceptions you say, unless you say, you could just say exception, which basically means all exceptions, and then it finishes because it catches all exceptions. Because as I was saying, all exceptions inherit from base exception, and most exceptions you want to catch inherit from exception. So that's important. So anyway, when we talk about this, so now here I'm saying, okay, I want to catch both value error and index error, right? And then I can have multiple except blocks in my try so that depending on what the exception was, I can do something different. So here, it just prints one of the indexes was not valid because I did my numbers 100. Ooh, notice the list comprehension here. Nice. Sometimes we want to re-raise an exception. So that means that like the exception happens, I handle it, I do something that I need to do, but then really I can't continue with my function or it's just we're irrevocably broken. And so I want to tell whoever called my function that like, hey, there was an exception. I want to re-raise the exception, right? So that's how we do this here. We accept the value error, we print out something, and then we say raise. So it re-raises the exception that happened. So this is a really convoluted example. So this is more, I think this is kind of like to study on your own, but basically I'm saying like parse string takes a string s and returns int s, right? If s is not parsable, it prints s is not an int, but then it re-raises, right? So then parse all strings calls parse string, right? So when parse string raises, this is in a try block, it would accept an index error, but it's not going to raise an index error. It's going to raise a value error. That's what this, that's what this comment is saying. This error never happens. Index error never happens. So it's just showing you that even if it's catching something, if it's catching the wrong thing, it's not going to do anything, right? And then here we have I think I messed this up. Oh yeah, this is just here. That's not supposed to be there. Okay. So what is it printing out? X is not an int, right? this is the same example from before. We have some numbers and an x in there, right? X is not an int, which is what this prints out, right? Then it raises. So it was in this call, it gets raised up. It's not an index error, so it gets raised up again. Parse all strings, it gets raised up to here. Then it says value error, that's the type of exception. So it prints not all strings can be parsed, which is what it printed. And then it prints program done. So, and notice that again, like numbers are blank, never gets printed because the exception happened here and then was caught. Not all strings could be parsed. Does it make sense that like the error happens, it gets caught, it gets re-raised, it doesn't get caught? Like, are we following this chain of thought here? The error happens, it gets caught here, we print this, we raise it so it gets thrown again into this block. Because this is index error, not value error, it keeps going up the chain into this block. And finally, we have a value error catch here. So it says not all strings can be parsed, which is what it prints out here. Not all strings can be parsed. The other thing I introduced in this example is the finally block. So finally any code in a finally block, finally is only for a try block, try except finally. Any code in a finally block gets executed whether there was an exception or not, right? So we call main. If there's an exception, it prints program had errors, and then finally it prints program done. Finally, like finally, at the end, no matter what. This is kind of like where you put code that's like, oh, I opened a file, and then a bunch of crap went down, and I don't know what to do. But at least I closed the file, because I said, finally, close the file. You know what I mean? Finally, no matter what, I need to report whatever numbers I tried to convert or something, so report it, And finally, yeah. So that's why I had the 42 divided by 0 in here. Because here it says program had errors. There's a divide by 0 exception in main. So program had errors. And now print program done in the finally. Before, this is something to understand as well. When I ran it before, it said X is not an int, not all strings can be parsed, program done. Why didn't it print program had errors? Why didn't it print program had? I mean, the program had errors, right? Not all strings could be parsed, so why didn't it print program had errors?
Did we skip over it?
Well, you removed the error there, so it didn't catch it. The divided
Where?
42 divided by 0.
No, that was something I added just to show that like the exception and then the program done. But now it's trying to parse all these integers, right? Parse all strings, right? That throws an exception and it prints not all strings can be parsed, right? See that? Not all strings can be parsed. And then it prints program done. Why didn't it print program had errors? Yeah, it never got there. I mean, we know that for a fact, right? Because if it had gotten there, it would have printed it. Why didn't it get there? All right. So hold on. Let's work this. So it never got there. How would it have gotten there? What would have made it get there?
interrupted with a, is it because of the, is it the try?
Basically, you're very close. Say it through more. You're very close. Go ahead.
Because we have it to operate until we get to this thing that it hits, but since it hits that, we kind of pass over to be like, oh, okay, we got this result, okay.
Exactly. So you're pretty much exactly right. So because we have this in a try except, when the error happens, we handle it, right? So now that error is done. It's handled. It doesn't go further up. It doesn't get to this level where it has to be handled by this, right? What if I put raise here? Now it says program had errors, right? Because now I'm handling the exception, but I'm also telling it to raise it up further. So now this code is throwing an exception, which is caught by this code, and it prints program had errors.
Is that why it's kind of, should raise? I guess this is a really silly question because if raise wasn't there, we could be like, oh, we ran this code perfectly. Here you go, you guys. I'm gonna like deploy this code. It has no errors, and then later on it could have like a bug, and then people will be like, well, where is this from? And then the person will be like, well, this didn't have any bugs or errors before.
Well, in a general sense, but what we're saying is it's like what I just typed, errors handled, don't re-raise. So like, we're saying like, no, something I called caused an error, I handled it, it's done. So it's exactly what you said, that I'm saying in my function, I'm like, oh, I handled that error, it's not causing a problem anymore. You know what I mean? It also might be the case that like, you just don't want your function to raise errors. Like you could possibly catch the error and then return none. And then the place that called your function knows, oh, if I get back none, then I couldn't reach the database or whatever. You know what I mean? Like, so, yeah. Actually, I realized that probably some of this might be easier to see, like, if we just did our own functions, like def say hello name if name is not equal to Bob. Yeah, exactly. So like this raises an error. You can raise your own errors just using raise, right? And you can use the ones that are built in. So like raise value error, not Bob. So here's my exception, not Bob. It's like a program I would write when I was 10 years old, right? Like, what is your name? If a name equals Travis, you are awesome. Yeah. Anyway. Okay, and we can also define our own exceptions. We just have to inherit from exception. This is like object-oriented syntax. We don't need to worry too much about it, except that I have like playground exception, inherits from exception. Name not given error, inherits from playground exception. Location missing error, inherits from playground exception. And I use the pass keyword here, which is actually appropriate. Usually when you're defining exceptions like this, they don't need any logic. You don't need anything, so you just do like class, my exception, pass. Just like this. Exactly like that. That's like actual code I would see in production. So then here we go with the playground stuff. Alice, Bob, Claire, and Dennis. And then we have some students, and we can see that Claire is missing a location, and John Doe is missing a name. So when I do the roll call, I do for student and students, right? So I'm iterating over all of these tuples. If student 0 is none, this is another thing, is none. I should write that up here for myself. Where was I going to put none? Oh, here it is. Okay. Sorry. Exceptions. Oh my God, we're over time. I'm so sorry. Let's just do we don't have to do any of these exercises. Let me just show you this real quick. So basically I'm saying, like, if the name is none, say name not given error. If the location is none, location missing error. And then otherwise I say student is at the student, blah, blah, blah. So I do the roll call and I check for this stuff. And it says Alice is at the slide, Bob is at the sandbox. But then I get, location missing error because I didn't run this. Boom. Run it again. And I get Alice is at the slide, Bob is at the sandbox, and then playground error, no location. So here, location missing error got raised. And even though I'm not catching location missing error, I am catching playground exception. And if we look up here, location missing error is a playground exception, right? Whereas if there was a name not given error, if I had gotten that far, it just says error missing name. So if there's something more specific, like the name not given error, it runs that first. Otherwise, I can also remove this. Oops. And now it says playground error missing name because the name not given error is a playground exception. This is something that maybe you should look at the notebook and read some of the explanations to really get it another time. Or in 3 weeks we'll be doing this lesson again. So there's that. Okay, any last questions? I mean, we did start pretty late, but any last questions?
How did you say if we didn't the homework? How do we put that?
Yeah, I'll add instructions to the wiki. So just check the wiki. I'll post in the Python when I have the instructions up. In the Python Discord. Yeah.
Well, I finally got in Discord, so.
Oh, good. Cool. Any other questions? No? All right. Thank you very much. Oh, and I have to say this. This class is free. I am a volunteer. I do not get paid, but Noisebridge runs on donations. So if you got anything out of the class or would like to contribute, please feel free to look at any of the QR codes on the walls or go to noisebridge.net and donate. Thank you.
Is there a recommended donation?
Is there a recommended donation?
Sometimes they list random numbers, but it's just like whatever.
Just out of curiosity, where did you get the nickname T-Money?
Oh, from high school.
Oh, really?
Yeah. Okay.
That stands for too much money, right?
Yeah, I wish. All right, thank you, everybody.